this is where we were at yesterday. Like I said, what we're gonna do is we're gonna finish these examples here, and then we'll have a little bit of time to work on some of these questions. After that, we'll have time to work on and discuss the next lesson, which is radian mode. Okay, so going back to this one here, determine the exact values of the 6 trigonometric ratios. Now, when we look at this 450 degrees, and we say, okay, well, where is 450 degrees? Which quadrant would that be in?
That would be equivalent of 90 degrees.
That would be an equivalent of 90 degrees, okay. So, go like that. And because we are talking about a positive degree, positive angle, we're going to rotate counterclockwise. So 0 all the way to 360 and a bit more. So we're stopping right there. That's our terminal arm at 90 degrees, or where 90 degrees is basically. Okay. That's a co-terminal arm of 90 degrees. So when we look at this 90 degrees, the values for that part, the x and y, is 0, 1. 0, 1. So that means this is the x, this is the y, and we said x is equals to the cos of theta. So that means cos of 450 degrees is x, which is 0. Sine of 450 degrees equals the y, which is 1. And then tangent, we have to remember what tangent is. Tangent is sine divided by cos, or y divided by x. So that would give us tan of 450 is equals to sine, which is 1 divided by 0, so it's going to be undefined. Okay? I'll just put the value here, 1 divided by 0. That kind of explains why it's undefined. Okay, so we have to do the secant, cosecant, and tangent. Secant of 450 is basically the reciprocal of this. Now, let's take a look. The reciprocal of 0 is going to be, it's going to be 1 over 0. 1 over 0. And that's going to give us the undefined. Cosecant of 450, it's 1 divided by 1, which is 1. Go like that. And then cotangent of 450, it's going to be 0 over 1, which is 0. Okay? Is that good? Now, I just want to show to you that when we type this in, this one will actually be our exact value. So let's go type in cos of 450 degrees. Did you get a 0? I got a 0, so yeah, so that's true. What about sine of 450? Did you get 1? Okay. And let's go tangent of 450. just for the sake of showing our answer here. Now I got an error. It's error because it's undefined. Okay, so far so good. Let's take a look at this one. Negative 225. It's a negative angle, so it's going to rotate clockwise. So where would that land? So 0, negative 90, negative 180, negative 270. So this is going to be, negative 225 would be there. Okay. What angle is this? 45 degrees. So that means our reference angle, theta r, is 45 degrees. Okay, now if it's 45, we already know previously the x and y value of this. Okay, so if it's over here, it's going to be positive for both. And what's the value? If it's 45 degrees, it's the same. It's going to be root 2 over 2 and root 2 over 2. But it's on the quadrant number 2, so it's going to be negative root 2 over 2, positive root 2 over 2. So this is negative root 2 over 2, positive root 2 over 2. This is a special angle. Okay? So from there, we can go cos of negative 225 degrees. That's going to give us, the cos is the x component, so it's negative root 2 over 2. Sine of negative 225 is going to be positive root 2 over 2, and then tangent it's sine divided by cos. Positive divided by a negative, it's going to be a negative. Okay, now let's go secant of negative 225. What would that be? Negative 2 over root 2. Cosecant of negative 225 degrees. It's going to be 2 root of 2, positive, and then cotangent is, it's still negative 1. Okay, is that good? So far. Okay, last but not the least, 690 degrees, and it's a positive, so it's going to rotate at the counterclockwise direction. Okay, so how many times would it go? Around 360 and 690 divided by 360 is 1 rotation minus 360. 330 degrees. So it's, you're going to go around 360, and then we're not going to stop there. We're going to keep going for another 330 degrees. So 330 would be like right there. So our terminal arm is in quadrant 4. Okay. So the angle in standard position is 690 degrees. What's our theta r? 30. Yeah, 30 degrees. So our reference angle is 30 degrees. What would be our x and y component of that. So 30. Okay. Here's your unit circle. 30. Yeah, this one would be a half. Yeah, but is it the x or the y? The y is a half, yeah. So this is 30 degrees, 45 degrees, 60 degrees, right? So this one here, x is pretty long. So that's the one that's root 3 over 2, and the y is a half, because it's a halfway between from the middle to 1, and our radius is 1. And 45 degrees, that's root 2 over 2, root 2 over 2, they're the same. And then this one would be a half, comma, root 3 over 2. If we remember these things, that's all you need to remember. Well,
Yeah, right on the hand.
yeah, unit circle.
I would totally do it. It's like you can't punish someone for that.
No, just get a
Just wear a
tattoo of
tattoo
the unit
for
circle
a
and
t-shirt and say it's the only thing you have that day, and that's it.
Yeah, that's true. How come I didn't think about that?
And next thing you know, she'll come with the quadratic equation.
Yeah, like I'll have like my arms full of formulas and all that, right? My cheat sheet on my arm. Not even under my sleeves, it's on my skin. Okay, so what would that be? 30 degrees, but 30 degrees, it's not in quadrant 1, it's on quadrant 4. So what would that be? It's going to be root 3 over 2, comma, negative 1/2. Yes? Okay, good. So, let's go for cosine. So cosine of 690 degrees is root 3 over 2. Sine of 690 degrees, negative 1/2. Tangent of 690 degrees.
Can you show the long way for that one again?
Okay, 690 degrees. We'll talk about that in right now. It's going to be some negative number for sure. Okay, so tan of 690 degrees is equals to sine of 690 divided by cos of 690 degrees. We already know what the sine of 690, that's negative 1/2, divided by the cos of 690, that's root 3 over 2. Okay. I'm going to show you a long cut and a short cut. I think I invented a new word, long cut.
My stepdad says it all the time.
It's not much of a
Huh?
test.
Long cut, because he always tries to take shortcuts and then take longer.
Oh, okay.
Calls them long cuts.
Yeah, there you go. See, I'm not the only one. So negative 1/2. When you're dividing, this is called a complex fraction because you're a fraction within a fraction. The same thing as multiplying the reciprocal. You know this from way back when. So it's going to be 2 over root of 3. So the 2's cancels, and then we're left with negative 1 over root of 3. Okay? So that's the long cut. What's the shortcut? The shortcut is this. Did you figure it out? Anybody? Negative 1/2 divided by 3 halves. This cancels. You're left with negative 1 over root of 3. Okay, then that's a shortcut. Okay, so now get back to this one. It's going to be negative 1 divided by root of 3. Okay, and then the other ones are so much simpler because all we need to do is just take the reciprocal of the sine, cos, and tan. So secant of 690 degrees is going to be 2 root 3 cosecant 690 degrees is negative 2 over 1, or just negative 2. And finally, it's going to be cotangent of 690 degrees, and it's going to be reciprocal of negative 1 over root of 3. So it's going to be negative root 3 over 1, or just negative root of 3. Okay? So far, so good? Now, yesterday we talked about the cast rule, right? Let's just see if it actually fits in our cast rule. The cast rule says here, over here in quadrant 4, only the cosine is positive. You look over. So you look over here, cosine is the only positive. Sine is negative, tan is negative. So it works. Secant is positive because all we had to do was just flip those two around, right? So that makes sense, and these ones are still going to be negative. So that one works. Do you want to give it a try? Go check it out. Go type in cos of 690 degrees. Let's see if we're going to get 0.8 something. So it's 0.866. That makes sense, right? It's positive 0.866, and root of 3 over 2 is 0.866. Go sine of 690 degrees. It's negative 1/2. That works. Okay? And that's our exact. And then finally, tangent of 690 degrees is, it should be negative a number, so negative 0.5. Good? Any questions there? Pretty clear? Now, can you see that these two are kind of opposite of each other? This one, we are given the angle and we're trying to figure out the sine, cos, tangent, and the trig ratio. Here, we're given the trig ratio. Now we're going to figure out what the angle, or angles, because there could be more than one, right? So, let's see if we can visualize this one. Our domain here, our theta has to fall between 0 and 360 degrees. That's a great thing, 0 to 360 degrees. So we look at this one. Sine of theta is equals to 1/2. We have to ask ourselves, what angle or angles where sine is positive? Because this is a positive 1/2, right? So, okay, so sine is positive in first and second, yes? Yeah. So we already know that with that 360 degrees, from 0 to 360 degrees, we're going to end up with two different angles. So let's see if we could figure that out. The sine, that means the y is 1/2. If this is a unit circle, 1/2 is here. That's your first angle in quadrant 1. And then this is your second angle in quadrant 2. Okay. So 1/2. Okay. And they're asking for, well, they didn't say this, but the exact value of theta. What's theta? What angle would this be so that it's going to be 1/2? 30 degrees. 30 degrees. Yes? So the 30 degrees is our reference angle. So that means in quadrant 1, theta in standard position is 30 degrees. And in quadrant 2, theta is going to be 180 minus 50. Oh, sorry. I already said the number. Back. Okay. 180 minus 30, and that's 150 degrees. So we have two angles where the sine of theta is equals to a half. Right? So these two angles. Good? Let's try this one. Cos of theta is equals to negative root 3 over 2. So we have to ask ourselves, okay, how many angles are there that will give us the x value being a negative root 3 over 2? Or, where is cos? Negative. So cos is negative in which quadrants? 2 and 3. Yes. 2 and 3. In quadrant 2 and quadrant 3. Okay, so by the end of this thing, the more you play around with this, it gets better, right? So negative root 3 over 2 is over here. It's root 3 over 2 is more than 0.5, right? It's 0.866. So it's going to be like super close, or getting closer and closer to 1. So over here. So that's there. That's there. So our first angle, that's in quadrant 2. Second angle in quadrant 3. You know what? For me, I like to see what I'm doing, but you don't have to necessarily draw if you remember what that is. Okay? So that means, what's the reference angle there? It's also 30 degrees, right? So theta r is 30 degrees. 30 degrees. So that means theta in quadrant 2 is going to be 180 minus 30, which is 150 degrees. And in quadrant 4 is going to be 180 plus 30. Oh, sorry, quadrant 3. Thank you. Quadrant 3 is going to be 210. Good? Next one. Tan theta equals to 1. Okay, we have to remember where's tan is positive in where? First and 3. First and 3. So quadrant 1 and quadrant 3. When you're doing this, can you picture it in your brain already? Can you imagine things? Okay, that's good. Okay, because you're just not memorizing it, because memorizing is one thing, understanding it and then memorizing it is much better. Okay, so, and then we have to take a look. Well, tan of theta equals to 1. If that's the case, then that means sine theta divided by the cos theta has to be equal to each other. And the only place it's equal to each other is if they're at 45-degree angle. Okay? theta r, our reference angle is 45 degrees. Okay, so in quadrant 1, theta is equals to 45 degrees. In quadrant 3, theta is equals to 180 plus 45 is 225 degrees. What do you think? It's pretty easy, right? Not bad. And you're starting to visualize. That's a great thing. Okay, that's awesome. We're going to finish off example number 3 right away, but I'm going to switch page here because I'm running out of space. Any questions before I go to example 3? Make sense to us? Okay, example 3. Now, I look at this and say, okay, for each of these trigonometric ratio, they gave us the trigonometric ratio. We're working backwards, meaning we want to know what the angle is. We're working backwards. On top of that, our angle has to fall within negative 360 to positive 360. Okay? So, let's see what we can do. So, example 3a. Secant theta equals to 2. Okay. Now, those special angles and the x and y coordinates only works for sine and cosine, right? But this happens to be secant. Now we have to use our trig identity. Secant is the reciprocal of cosine. Okay? So when we say secant of theta is equal to 2, that means the cosine of theta must be 1 over 2. Yes? Is everybody okay with that? You want to see it? The long cut? Are you convinced already?
I think I can see it, but
You
I don't know.
You think you can see it, but you don't know? Okay, let's see it. Okay. So let's see. I'm gonna just go on a separate sheet of paper here. Secant theta is equals to 2. We said a secant theta is 1 over cos, yes? Yeah? They're reciprocals of each other. So if I take reciprocal of this, I'll get the secant. If I take the reciprocal of this, I'll get cos. Good? Actually, I'm gonna even 1. Oh yeah, I'm okay with that. I'm okay with that. I'm convinced. Okay, is that good? So now what we're gonna do is I'm gonna have isolate the cos and in the numerator. So I'm gonna cross multiply there. So that becomes 1 equals to 2 cos theta. Now you're gonna probably starting to see it. Divided by 2, divided by 2. So cos theta equals to half. Yeah, so cos of theta is equal to half. So that's peace. So think about, where is cos theta a half? 60. Did you already go home last night and memorize these things? That's pretty good. No? You just remember. Yeah. So cos is x. If this is 1, the radius is 1, half is here. The way you can only get half is if your angle is way up there.
It has to be positive, correct?
Yeah, positive, right?
2 has to be.
Oh, it'll be positive there too.
Hmm?
And as well as below.
What's that? Yes. Yeah. So cos is positive in, okay, you're ahead of me. That's fine. Yeah. So I'm just saying that the angle is over here, which is 60 degrees. I'm just showing you that it's not over here, because this is going to be 30. And cos is a half. Cos is positive here as well. Okay, so our reference angle is 60 degrees. Theta r equals to 60 degrees. So therefore, in quadrant 1, it's going to be theta equals to 60. And in quadrant 4, theta is equals to 360 minus 60, which is 300 degrees. So we have two angles that will give us a cos of that angle to be a half. Yeah.
It has to be between negative 260 and 260.
Oh yeah, that's right. I forgot about that. That's just from, this is just between 0 to 360. Oh, yeah, okay. So now I gotta go the other way. These are the positive ones, positive angles. Now I gotta do the negative angles. So what would be the negative? We have to go this way, negative 60, and then negative 300 degrees. And these are the negative thetas. Good. So far so good? Yeah. Letter B. Cotangent. Okay, so what do you think the first thing that we gotta do?
Find the reciprocal.
Tan. Yeah. So tangent of theta is equal to the reciprocal of negative 1. What's a reciprocal of negative 1? It's also negative 1. So where is tan? Negative. Quadrant 2 and quadrant 4, yes. But for this to be negative 1, that means the sine and the cos have to be equal to each other. And the only time they're equal to each other in absolute value is if it's a 45-degree reference angle. So this is 45-degree reference angle. Okay, so that means theta in quadrant 1, theta, oh no, not quadrant 1, quadrant 2, is going to be 180 minus 45, so that gives us the 135 degrees, and in quadrant 4, it's 360 minus 45 degrees, 315. These are the positive angles. Okay. What's a negative angle? If we go to the negative angles, it's going to give us negative 45 degrees. And The other one would be negative 180, and then another negative 5, it's going to be negative 225 degrees. So these are the negative angles. Letter C. Sine is 0. Oh, sine of theta is equals to 0. Where is sine 0? That means where is the y value 0? Right on the x-axis, right?
Yeah.
So that means theta has to be 0, 180, 360. That makes it all the positive angles and the 0. Now if you go the other way, negative 180, because if we go the clockwise direction, and negative 360. Good. So at this particular point, we have a little bit of time to do some of the questions that's been assigned to you. Okay, so if you've started this last night, great, continue on. If this is your first time going through these questions, it's highly, highly recommended to get a lot of practice. Okay, so I'm going to pause this video right now so we can work on this. Feel free if you have any questions to come approach me if you have anything. Okay, so we'll pause and then we'll resume in a few minutes.